Hey guys, I'm going to attempt to teach this lesson on absolute values. There may be some interruptions, so we'll just see how it plays out. We'll try it and go from there. Okay, so again, we're talking about inequalities. We've been doing solving inequalities, and we're going to look at absolute value inequalities. So I hope you remember that absolute values are the distance a number is from zero on the number line. You're probably thinking, oh, absolute values again. Maybe you don't remember them. Maybe this is you down here with the struggle is real. Or maybe this is you. Oh, yep, nailed it. I remember what absolute values are. But either way, we can all get to this point because absolute values are the distance a number is from zero on the number line. The distance a number is from zero on the number line. And think about when we're talking about distance. When you're talking about distance, you never say I'm going to travel -3 miles. So if I'm looking at the distance that -3 is from zero on the number line, we've got -2, -1, 0, 1, 2, 3, or the distance that 3 is. They're both just 3 units away. So when I take the absolute value of a negative number, it's still a positive because we're talking about how far that number is away from zero. So the absolute value of -3 is 3. The absolute value of 3 is 3 because both of these numbers, -3 and 3, are 3 units away from zero on the number line. So what does that mean then when we're looking at inequalities? Think about it this way. We're looking for values of x that are fewer than 5 units away from zero on the number line. So thinking about this, we're looking for numbers that are fewer than 5 units away from zero. So we got -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All of these numbers, I want to put an open circle here because I don't want them to be exactly 5 units away from zero. I want them to be fewer than 5. So I'm not including 5 and -5, but all of these numbers in between here are fewer than or less than 5 units away from zero on the number line. This number is 1 unit away. This one's 2 units away. This is 3 units away. This is 4 units away. And all of the numbers in between 4 and 5 are fewer than 5. Same thing on this side, 1 unit away, 2 units away, 3 units away, 4 units away, and then everything in here is somewhere between 4 and 5 units away. So this looks like an AND problem, and it is an AND problem. We're looking at the values of x that are less than 5, and at the same time, we're looking at the values of x that are greater than -5, right? So they have to meet both of these criteria. They have to be less than 5, and at the same time, they have to be greater than -5. All of these numbers in between here meet both of these criteria. They're less than 5, and they're greater than -5. So when I write that using my interval notation, I say, okay, it starts at -5, goes up to 5, and I'm not including them. If I'm using set builder, we say x such that x is sandwiched in between -5 and 5. So now thinking about the values of x that are greater than 5. We're looking for values of x that are more than 5 units away from 0 on the number line. So we've got 5 out here, we've got -5. I'm just going to count by 5s here. -10, 10. So I'm thinking about this. If I start at 5 and I go out this direction, all of these numbers out here are going to be more than 5 units away from 0 on the number line, right? Starting at 5, all of these out here are more than 5 units away. Starting at -5 and going down this way, all of these numbers are more than 5 units away from 0 on the number line. So these numbers out here are true, or these numbers out here are true. So we're saying all the values of x that are less than -5 or all the values of x that are greater than 5 meet this criteria. See the difference between and or? Think about it. If for Christmas you were asking for a PlayStation and an Xbox. You are one greedy little kid, right? You're wanting the Xbox Series X and the new PlayStation 5. You must be asking your parents for an awful lot because you're wanting both things. So think about that in regards to math. We're wanting both things to be true. They can be greater than -5, and at the same time, they can be less than 5. Okay, maybe you're not such a greedy kid. Maybe you're like, look, mom, dad, I know it's really hard to get either the Xbox Series X or the PlayStation 5. Like, it's impossible to get them. So, whichever one you can get, I'll take it. I'll be happy with it. So, you can get me Xbox Series X. We'll say that's this down here. Or you can get me PlayStation 5, whichever one. I don't have to have both. I just have to have one or the other. So all of the x values that are less than -5 or all the values that are greater than 5 will make this inequality true. So the way that we write that, this one's a little bit confusing in interval notation. Again, we always start reading left to right. So this is pointing forever and ever and ever down here towards negative infinity, comes up to -5, and it stops. We don't want to include these values. So to show that there's a break in the graph, we use this U symbol. It means unioned. So all of these symbols unioned with all of these out here. All right.